Hi there. Today we're going to learn about range, quartiles and interquartile range, and we're going to have the pleasure of EastEnder celebrity guest teachers. For you to be wanting to learn about this lesson, you must already know a bit about averages. In particular, you should know how to calculate the median of a set of data. The objective today is to find the interquartile range of a set of data. In order to find the median or the interquartile range, you'll need to place the data that you have in order of size. So first of all, I'll give you just a few seconds to rank these weights in kilograms in ascending order. Ascending means start with the smallest and work your way up to the biggest. So the smallest, you should agree, 36.0 kilograms, followed by 43.4, 43.5, 49.9, 56.1, and the largest mass is 56.2 kilograms. That is the prerequisite for today's lesson.
The range equals the highest value of a data set, take away the lowest value of a data set.
So if you have a data set, all you do to work out the range is have the biggest take away the smallest.
The quartiles Q1, Q2 and Q3 split the data into 4 parts.
Now that's an interesting notation, Q1, Q2 and Q3. You should already be aware of Q2, although not in this format. Q2 is simply the median, which is exactly the middle value. If you have the lowest number here and the highest data value here, the median value is the one in the middle, Q2. Q1 is a quarter of the way along, hence it is called the lower quartile. Q3 is 3/4 of the way along, or a quarter of the way from the highest value, hence it's called the upper quartile.
Q1, the lower quartile, is a quarter of the way through the data. Q2, the median, is halfway through the data. Q3, the upper quartile, is 3/4 of the way through the data. The median equals Q2, which is equal to a half times the number plus 1.
So n is the number of values that you have. To work out the median value, you just simply count the number of values, add 1 to it and half it.
The lower quartile equals Q1, which equals a quarter times the number plus 1.
The quartile calculations are exactly the same. For the lower quartile, instead of halving the number of values plus 1, just simply take a quarter of it.
And the upper quartile equals Q3, and that equals 3/4 times the number plus 1.
The quickest way to work that out is to calculate the value for the lower quartile and multiply it by 3.
The interquartile range is equal to the upper quartile take away the lower quartile.
Now you've calculated the range before. The range is the largest, take away the smallest. The interquartile range, the grade B topic, is simply take the highest quartile, the upper quartile, and minus it from the lower quartile. So it's a range over a smaller spread of data. It doesn't take into account the extreme ends of the data, which are normally inaccurate. Most of the accurate data is within the quartiles. That's why the interquartile range is such a good statistic to take. Here's an example. In meters, we've got the heights of so many trees. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 trees are measured, have their heights measured in meters. Our job is to find the interquartile range of these heights. Just a quick question for you. If there are 15 trees, What is the value of n for this example? Yeah, it will simply be 15.
Firstly, write the heights in order.
Remember, like for the median, which you should have learnt before, you cannot perform any of these calculations unless the data is in ascending order, smallest to biggest. 4's the smallest, 6, 7, 10, another 10, 12, 2 18s, 20, 2 24s, 27, 2 30s, and 31 metres.
Then we need to find the lower quartile and the upper quartile.
The question is find the interquartile range. We're not interested in the median value, Q2, because we just want the upper minus the lower. Well, what is the upper and what is the lower?
The lower quartile value equals a quarter times by the number that there are plus 1.
Okay, so we have 15 trees. So n is 15, n plus 1 is 15 plus 1, 16. What's a quarter of 16?
Which equals quarter of 15 plus 1. Remember in your bidmas, that becomes a quarter times 16.
16 shared 4 ways.
So lower quartile equals the full value.
Be careful here. So many candidates will say that the lower quartile is 4. Well, that doesn't make sense because the smallest tree is 4 metres. It's not 4 metres which is the lower quartile, it's the fourth value. So now you've got your trees in order, you just simply count along 4 values. 1, 2, 3. The fourth value is here. Therefore, the lower quartile is 10 metres for this example.
The upper quartile value equals 3/4 of the number plus 1, which equals 3/4 of 15 plus 1, which equals 3/4 times 16.
Well, first of all, I don't remember M&M ever appearing in EastEnders. And secondly, the quickest way to calculate the upper quartile is the lower quartile is the fourth value, multiply the fourth by 3.
Which is 12, so the upper quartile value is the 12th value.
Be careful, the upper quartile value is not 12 metres, it's the 12th value. 12 metres for the upper quartile doesn't make sense. The upper quartile has to fit along this side of the data. Let's count 12 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The upper quartile for this example, for this set of data, is 27 metres.
Remember that the interquartile range is just simply the upper quartile take away the lower quartile. So the upper take away the lower, that's Q3 take away Q1. The upper quartile is 27, the lower quartile is 10. So you just simply do 27, take away 10. That's 27, subtract the 10, which equals 7.
No, it equals 17, Lee, but good try. This slide says homework. This is your homework. I haven't got the answers for this as a PowerPoint, but see if you can just quickly freeze the screen and have a go at working out the quartiles, including the middle quartile or median of this set of data. The mass or weight of seals, how heavy seals are. Don't forget, you need to write the values in ascending order. You need to know how many there are because the quartile values is n plus 1. Once you've got your lower and upper quartiles, take one from the other to get into quartile range and compare that with the whole range, the largest seal minus the lightest seal.